All right, so I can start. So I'm excited to introduce Shishir, who is one of the grad students who probably built the biggest empire that I've seen here at Berkeley, the Team Gorilla. So when Shishir came to Berkeley, he came here with a background in embedded systems, embedded machine learning, actually pioneering that space. Then came here and actually did quite a bit of exciting research in that space, then transitioned to doing work in security and network systems, and then built up, as I said, an empire around function calling, around Gorilla initially, and then open functions, Coex, and then now a whole leaderboard system that's become kind of the industry standard for function calling. It is so successful that I was looking at videos by Andreen recently, and it cites Shishir's work as defining the function calling space, which is pretty exciting to see. So Shishir has a lot of impact, both open source and in research. Excited to introduce Shishir.
Prabal, maybe you should go. You know, you are remote, so I don't go.
Sure. So it was great to get Shishir first when he got to Berkeley, and you know, I think this is a really great example of an arc of independence that's amazing. So he'd done a little bit of work in ML and work in embedded systems, and I think he was really ahead of the curve on what has now become TinyML, and he kept wanting to push things and using all sorts of terminology that I had no idea what he was talking about. So I said, hey, you need to get some co-advisors who actually know what you're talking about, which is, I think, how, Joey, you got involved in this. And I'm happy to say that the roles are totally reversed. I learned way more from him now than I think he ever learned from me. So it's really great to see everything you've done and, you know, the impact your work has had so far.
Yeah, so not much to add. What can I say? Shishir is very creative on many dimensions. He pushes the boundaries on many dimensions. Awesome. And his breath is spectacular. And I think, you know, there is always a question about the right balance between focus and breadth. I think it's pretty much on the Pareto optimal curve. Really, I collaborate with him mostly the past year and a half, and I really enjoyed. Always, every meeting is different. It's different from what I expect, and new ideas, and really very enjoyable. And what he has done is very impressive, and I cannot wait to see what he's going to do next. But between now and then, the difference. So, Shishir, please take it from here.
Yes. Everyone, thank you so much for coming to the talk. I'm honored to have all of you join. And also thank you, Joey, Prabal, and Jan for the generous introduction. So today's talk is going to be on teaching LLMs to use tools at scale. And so I thought it'd be fun to frame my dissertation talk not by looking back, but actually by looking forward. So I want to make 3 bets about where the world is headed. And then I'm going to tell you all about the work that I did and how I think it supports these bets. So here are my 3 bets. The first, it is easier done than said in LLM parlance, right? And if there's something that needs to be done, just do it, do not say it. And what does this mean in terms of LLM land is something that I'm going to explore in today's talk. My second bet is it's going to be fine-tuning everywhere, right? And oftentimes, if you're been working in this LLM space, you might have heard, hey, is it small language models for fine-tune? One size fits all large language models? I don't think so. Be it large, be it small, be it somewhere in between. Fine-tuning is the way to go everywhere.
Yeah,
And so,
share your screen, Shishir, sorry.
No.
Do you also have people in your waiting room?
Oh, yeah.
Do you have people in your waiting room?
Who owns this call? Is this Taurus?
Yeah, it's yours.
I can jump. I guess you think it goes.
okay, so housekeeping. More time for you guys to ponder on the bets.
Okay.
Unless you want to kick.
Okay, excellent. Let me share screen. Okay, awesome. So these are the 3 bets, and each of these bets relates to a few of the projects that I've done, and I'm going to talk about, and how I think that my projects will support some of the bets in the future. Okay. So first step, it is easier said than done, to it is easier done than said. So I'm going to start off by talking about the Gorilla project. And the goal with the Gorilla project was to teach LLMs to use tools at scale. Now, let me start off by looking at the current current paradigm and how people use LLMs, right? So on the left-hand side, I have listed a bunch of LLMs. Pick your favorite that you put over here. Now, on the right-hand side is a big digital world, right? But fundamentally, you are at the center of it. So today, if you want to talk to an LLM, you prompt the LLM.
Sorry. You have people in the waiting room.
And then you get a response. Now, I've shown this as a single shot interaction, but oftentimes you can think of it being multi-turn, and there's a whole cottage industry of tools that help you do this better, right? So Llama Index, LangChain, so on and so forth, all help you in this direction. But fundamentally, it's up to you as the user to then take this response that you get from the LLM and then perform an action on the world and get a response, right? So for example, many of us would like to do some machine learning research. So if you ask an LLM, how do I install CUDA on my Linux machine? And the LLM would give you, here's a bunch of command line instructions. You take these instructions, and then you go and execute these instructions on your CLI and get a response. Now, many people think this is good. I think this is bad, right? And here's why.
Can you make me host so I can let the five
Yes.
people in? That way it's not popping up there. Or close.
Okay. So I think this is bad for the following reason. You took the most interesting part of my job, which was to write code, in some sense, the most creative job. And instead, you made me review shitty code that an LLM generated, right? So this is not very ideal. Instead, what we proposed is, can we flip this around? And so Gorilla is the LLM that we trained to do this. So the user is going to prompt the LLM, which is Gorilla. The LLM is going to perform an action. And then the LLM is going to read the response and then relay the artifact back to the user, right? So for example, if you want to install CUDA on your machine, the LLM would perform the action and the artifact is that you have CUDA installed. Now, this might seem a little too abstract, but why are we doing this, right? So this is based on this fundamental thesis that humans are good discriminators, we're not good generators. So we have a bunch of grapes in front of us. If I ask you which of the two grapes do you like, you probably can't tell which one is sour and which one is sweet. But if you get a chance to eat them, then you can very quickly tell me which one is sweet and which one do you prefer, right? So similarly, let's have the LLM perform the action, and the humans are now going to discriminate and say which one they like and which one they don't like and retain the action. So let's take an example. A common ask in our lab is we want 800 GPUs in let's say East US, right? So there's a few things we want the LLM to do, and this includes reasoning, planning, and execution. Now it needs to reason and recognize that East US is how Azure names its regions. In AWS is US East 1A, and GCP has US East 1, and then -A, etc. So you first recognize that this is an Azure view of the world. And then you go ahead and you actually want the LLM to, as retail users, many of us have quotas. So check if you have the quota to allocate GPU or not. And if you do, then instantiate the instance and pass the artifact back to the user, which in this case would be an SSH session into your instance of choice. So this is the workflow that we envisioned with Berkeley. So we start off by trying to support a bunch of machine learning APIs because we're trying to write a paper. It's like talking to your audience, right? But since then, the product has evolved. And so today, Gorilla supports about 60,000 APIs. This includes all the hyperscalers like Azure, GCP, AWS, your developer tools like Kubernetes, CRM tools, Salesforce, Datadog, ServiceNow, etc. And also, of course, the machine learning APIs. So the TLDR is the user comes in with a prompt. The LLM recognizes which of these tools to invoke, actually invokes the tool, performs an action, and then relays the response back to the user. So how did we do this, right? So there's two key ideas that helped us train the Gorilla LLM. The first is retrieval-aware training. Now, one of the questions that we had to answer starting off was, this popular question, do we mix fine-tuning and retrieval? And I use fine-tuning generously over here to also include RLHF, parameter-efficient tuning like LoRa, full parameter tuning, so on and so forth, right? And retrieval is your classic RAG-based scenarios where you have additional in-context that you give to the LLM. Now, the wisdom of the crowd when we started was that fine-tuning is to augment the behavior of the model. So you don't want the LLM to say toxic stuff. You want it to give you structured output, so on and so forth. But retrieval was to introduce new knowledge to the model. So this was the wisdom, right? This is where things stood. Now, what we found with Gorilla is that fine-tuning is actually quite remarkable and is remarkably effective at both behavior and at knowledge, right? Does this mean fine-tuning is all you need? The answer is no, right? You still need retrievers for data freshness. But the problem is retrievers tend to be inaccurate. So inaccurate is not the right phrase here. By accuracy, you're referring to recall at k, right? So if you have a retriever and if you go to ping it and take the top k options, you have an answer at least at 1 to get good recall. So retrievers are famously inaccurate, right? So I mean, this depends on how good or bad it is. But what we find is that in domain or of domain, all aside, typically retrievers are somewhere between 70 to 80% recall at 3. Now, many of you may argue that's a good number, but if you are trying to make this into a real solution, it means you're wrong 1/5 to 1/3 of the times, right? That's not great user experience for any application. So what do? The solution that we propose is called RAT, which stands for Retrieval Aware Training. And the idea here is that you want your LLM to double check your retrieval, right? So every time you're doing something, and if your retriever tells, hey, use this K documents, your LLM is going to implicitly make this one bit decision. Is this retrieved documents relevant for me? Is it not relevant for me? If it's relevant for me, I'm going to use that to answer the user's query. And if it is not relevant for me, then I'm going to discard it and instead rely on my knowledge from my pre-training or post-training to answer the question, right? So it's a test time, implicit. You're asking the LLM to judge and evaluate your retrieval. Now, how do we do this? The TLDR of it is that you're trying to introduce both correct and incorrect retrieval results during instruction fine-tuning. Now, there's a few more tricks that we do, but what you're trying to do in terms of code is you're trying to make your LLM robust to low-quality retrievers. So retrievers are going to be there. Can we improve it? Yes, we should keep doing that. But fundamentally, you're never going to get a recall 100%. So can you take the help of your LLM to step in when your retrievers are not fully accurate, right? Joey and Jan have been pushing me to keep it for an hour. So in the interest of time, I'm not going to go much into the details, but I would invite everyone to read the paper to learn more about retrieval aware training. The second question that we had to answer is, trying to ask this generic question, how much does GPT-4 hallucinate? I'm not going to do, actually, let's do it. Any suggestions? How much does GPT-4 hallucinate?
4.
Excellent. Well, Lisa has been in this domain, so I haven't asked her the least count, not the units. But when you attempt to ask this question, and most of you may think, hey, GPT-4 hallucinates less than 3.5, more than 3.5, more or less 4, right? Now, acknowledging that hallucination is ill-defined for a general purpose domain, what I'm going to claim is that you can actually define hallucination for API calls. So I'm going to define it, and I'm going to give you a metric to measure it. So the way we're going to do this is by using this classical concept from PL called abstract syntax tree. So let's take an API call. This is a Pythonic API call, which I'm trying to load a DenseNet one-to-one model from PyTorch. The first thing that I'm going to do is I'm going to try and build an abstract tree out of this. Then I'm going to look at all the set of APIs that a service provider gives you and ask a simple question. Is this API that my LLM generated a proper subset of this APIs that a service provider gives you or not? Now, my claim here is that given a snapshot in time, the set of APIs that's available to you is fixed. Across time, APIs may vary, but at a single point in time, the set of APIs is fixed, right? So then we ask the question, and if it is a proper subset, then we claim that the LLM generated API is not hallucinated. Now, keep in mind, I've made no comments on accuracy. Right? So this may or may not be relevant, but I'm going to claim that this is not hallucinated. And so this is our technique and how we measure hallucination for API calls. Now, there's a few implementation details, right? So for example, some of them may be string matches. So if DenseNet one-to-one is the argument that your LLM generates, you want to check for an exact 1:1 match in your set of APIs that the service provider gives you. But oftentimes, something like temperature in a chat completion call is a floating point value from 0 to 2. So then you're trying to look for a range and see if it matches the range or not. And oftentimes, pre-trained equals true might be an optional argument. So then you don't really want to check for that, right? So that's the idea. So we used this measurement and then the RAT training to now train the gorilla model. How well does it perform? So on the x-axis here, I have hallucination. I just explained to you the metric, lower is better. And on the y-axis, I have accuracy, higher is better. One does not mean the other, right? So suppose I want to give $100 to Joey so that he passes me on this dissertation. I can either use PayPal. If the LLM tells me to use PayPal, which is the right API to call, then it's accurate. But if the LLM told me to use the DenseNet one-to-one API from PyTorch in the previous slide, it's not accurate, right? You can't really send money with that. but it's also not hallucinated. So by hallucination, I mean, if you run this call, are you going to get a 404 if it's a RESTful API call? Or are you going to get a stack trace because your interpreter errored out, right? So if it tells me use the tensor 1-to-1, I don't claim it's accurate, but it's also not hallucinated. On the other hand, if it says use Berkeley API, then such an API does not exist, right? So then we claim that as hallucination. And so what I'm going to show here is a zero-shot graph. And of course, the top left is better. And this is what if you were to use a retrieval, right? And why do we use the retrieval? Because freshness of data, remember? So if you're trying to use the retriever, GPT basically stands for text.r002v2, which was a state of the art. Then I think text embedding small, large is the state of the art today from OpenAI for embeddings. An Oracle retriever is one where, if you knew exactly which document to use, then how would the LLM perform? And what we show here is that across all three scenarios, Gorilla matches and beats not just the open source, but even the closed source models out there today. Now, having come up with this hallucination metric, you can actually get a lot more insights, right? Suppose you don't care about APIs at all. You can still look at this graph and go, well, I can see that in the zero-shot case, GPT-4 hallucinates more than GPT 3.5, even though 3.5 is way more accurate, right? And we know that GPT-4 was lightly RL head shift compared to 3.5. So you can probably draw an arc back and say, that's why you're seeing the artifact that you're seeing. So a lot of interesting things. And we used this hallucination as a metric to also build the Berkeley function calling leaderboard, all right? And many of you may come from recommendation ranking or some of the other systems. And oftentimes, in a lot of deployed systems in the world, you look for online metrics, right? Like click-through rate. The ultimate call of humanity is to show better ads to people, right? As computer scientists. And how you know you're doing a good job is to see how good your click-through rate is. But that's an online metric. And the offline metric there is NDCG, which is normalized discounted cumulative gain. So similarly, in calling APIs, you can execute the APIs, which would be an online metric, or you can check for AST or abstract syntax tree that Gorilla introduced, which would be an offline metric. And you can see how good your LLM is. So anyway, that's the Gorilla idea, the recipe. Does it work? How good is it? And the answer is yes, right? So since the time we have released Gorilla, it's been used at a whole bunch of places across different form factors. So the idea here is how do you train an LLM to call APIs? This could be Bash APIs, command line API, sorry, Bash is command line, RESTful APIs, Pythonic, JavaScript, Java APIs, so on and so forth, right? What's more interesting for us is a lot of people have taken the recipe of Gorilla and trained their own models, and they've written open blog posts on how they've done it, right? So this has become a little bit of a life of its own. And, being the first to make this bet, a lot of researchers whom we respect have recognized and endorsed Gorilla as a step in the right direction, right? So we've been on international and domestic media quite a few times, and a lot of leading frontier labs have also collaborated with us directly, oftentimes by raising pull requests and, sharing with us, getting us to talk to them, consult with them on how you do function calling across the different models that some of you might have used. So that's, all good. But one of the things that's true with Gorilla is that you still have to train the model, right? Now, oftentimes you may not want to train the model. Why is this the case? Cost is a common answer, but more increasingly, you don't want to train models of your own because you don't know how to evaluate models. Evaluating LLMs is hard. Perplexity in itself is not a good score. So people tend to look for downstream metrics to evaluate LLMs. And so given an evaluation is hard, can we train one model that most people can use? Right? And if you think about it, Gorilla does three things, right? Discovery of APIs. If you tell it, I want to send money, it's going to tell you use PayPal. Second is structured calling. And third is filling the right arguments. If I want to send money to person X, it tells me an API call with person Y. That's not very helpful, right? The wrong person is going to get my money. So we said, okay, let's try to fix 2 and 3, which is getting the right structure and filling the right arguments. And instead of the discovery part where you fine tune the model, let's actually use RAG, right? And so that's function calling. We started with the idea, but OpenAI has gone ahead and pioneered the idea, right? So when we did this, they were at plugins, etc., and now everybody does function calling, although in the JSON schema. So we said, okay, what's next? And there's a few interesting directions we want to step into. The first is, can we actually make this more robust? So on the left-hand side is simple functions. So the question is, what is the weather in Berkeley? And the function you have is the weather API, and these two go as input to the LLM. Now, what the LLM is going to give you is the weather the API called, picking in the right argument, which is Berkeley. Now, you can try and see how you could expand this, right? So one of the things is multiple functions. but your retrievals can be inaccurate. So can I pass in k different functions into my LLM with a question? And you want the LLM to pick the right method, the right API call, and fill in the right arguments. And the third is parallel functions, where you ask the question, what is 2 plus 3 and 4 plus 5, and give it a single function, but you want the LLM to call this twice. What's challenging here is to maintain structured format, so on and so forth. I've shown you toy examples here, but you can quickly see how these examples, how these could actually get pretty complex. If you ask what's the weather in Palo Alto and in Berkeley, then you want the LLM to call the weather API twice, once each with Palo Alto and Berkeley, right? And most critical and the hardest thing to do is to make the LLM say, I don't know, right? So if you want to ask a question and the LLM give it a bunch of functions that's not relevant, can the LLM come back to you and say, hey, look, this is not very relevant. Can you either give me more functions or help me how to proceed? And this is something that we also pioneered with Open Functions V2. And more critically, what we said is let's move away from the classic data types of JSON and XML, is how OpenAI, Anthropic, Gemini do function calling, to actually go and support native data types of Java, JavaScript, Python, C++, etc. Right? We all know React runs the modern web. Can we go ahead and actually support these data types? So when the user comes in and says, I have a mortgage on a loan, I have a mortgage on a house at 5% interest rate, you can actually say, is it 5 an integer or 0.05 a floating point value, as opposed to just number in the JSON format that you get to use today. So that's Open Functions V2. And this is just a quick snippet to show when we did this, right? Given how quickly this field moves, the expectation was that in a couple of weeks or 3 weeks, we would have others come and train better models. But even to this day, it's been a couple of months. Open Functions V2 continues to be the best state-of-the-art model out there. That's Apache 2.0 licensed for function calling. And like I said, we not only support the classic JSON schema, but also a whole bunch of additional data types and some new techniques as well for can you mix parallel and multiple function calling, so on and so forth. Okay, let's take a moment back. So where are we? I showed you a bet. I say, let's do. It's better done than said. And everything that I've shown you so far is steps towards that direction, right? How do you train a model that can call APIs? And in cases where you don't want to train a model, can you use the function calling feature of these models to get structured input that you can then use? And the Berkeley function calling leaderboard was a way for us to actually see how well we perform, but has increasingly become the standard that people go to today to try and see where the different models compare on function calling. And we have a lot of interesting ideas on how do you measure contamination, and how do you try and see, well, is function calling really working? How do you isolate between, is this a fault of the LLM, or is it because your network is down, or is it because the service provider is not really able to respond to it? So that's all steps towards this direction. Are we doing on time? Excellent. Okay, so the second bet. The second bet was fine-tuning is going to be everywhere, right? Independent of small, large, you're not going to have a one model fits all. You will have to fine-tune. And so in context learning alone is not enough. And the project that works in this direction is Raft. So Raft stands for Retrieval Aware Fine-Tuning. And if you're wondering, is it similar to RAT? That's Retrieval Aware Training. The answer is yes, right? So with Raft, I'm not going to go too much into the details, but I'm going to give you an analogy to help you understand what the goal of the project is. So I'm a PhD student, and I've had to take a few courses and give exams, right? So how do I prepare for an exam? I prepare for an exam by studying for it. Now, in LLM parlance, this is training the LLM, right? So you train the LLM to understand the knowledge, so it can then go and answer the question when the user asks it. There's another way you can give an exam, right? You can put me in a room, give me a bunch of questions, and give me all the textbooks that you have. So that's the open book exam setting. But here's the problem. I'm trying to be a CS PhD. If you put me in an exam in the law school and give me all the textbooks on law that exists, I'm still not going to be able to do too well because I'll have no idea which textbook to even open or where to begin, right? So in LLM parlance, this is like RAG scenarios. If you ask it a question, give it a bunch of documents in context, no matter how big your in-context capacity is, it's very hard for the LLM to figure out where do I even start? What do I even look into, right? Now, if you do one thing, which is you give me the textbooks ahead of time, and you let me revise myself so I can build an index of all the chapters, or I can try and understand what's in each textbook, then if you give me the question, even if it's a law school, I can probably do much better, right? So that's the key idea behind Raft. Can we lightly fine-tune the LLM in domain so it can answer questions even by knowing how to reference the documents better, right? So if you have a medical domain or a legal domain, you train the LLM, you still do RAG, but now the LLM knows which ones to discard, which ones to use. Now, the ideas we use here are similar to Raft, but we also introduce a bunch of new concepts, right? So a few of them are, can you make the LLM verbatim cite which document was relevant? So if you have like 100 documents that you give it in context, can the LLM cite which of these documents is it going to use to then answer the question? Of course, we also introduce a bit of chain of thought style response where the LLM tells you why it's doing what it's doing. And the other thing that we try to do is, can we actually discard some of the answers from the LLM so the LLM memorizes, right? So if you were to have a document that says, find me the capital of the United States, and you had a document that said Seattle is the capital, you don't want the LLM to say Seattle, but you want the LLM to recognize that, US, Washington, DC is the capital, so I'm going to respond with that. So that's the context here. Your RAG could be noisy. So the question is, how do you now help the LLM understand some context so it can also discard some noise in your RAG documents? In short, Raft is a training procedure for open book Q&A. And for all of you, if you're doing RAG, you should be doing Raft, right, as a way to train the model. So where does that fit in? Well, we took some of the ideas from RAG, which was for API calls, made it a lot more general purpose. So you can now try it on legal domain, medical domain, so on and so forth. And we introduced this as a concept for RAG. Great. So the third bet is the future is human out of loop, right? Increasingly, a lot of people have been going towards co-pilots. My question is, let's remove the co and just make it pure pilots, right? So that's the key idea here, or that's the vision, right? And so the project that I worked on that helps realize this vision is Coex, which is an execution engine. Since we are in systems lab, I want to make this pretty clear that this is not an inference runtime, right? So this is not TGI, VLLM, etc. Our goal is not how do we make LLM inference faster, but our goal is to take the response that the LLM gives you, which we are going to generously call actions to include code, API, so on and so forth, and then actually execute these actions in the real world. All right, so that's the goal. Well, why is this hard, right? Or what's new? If you have humans out of the loop, what changes? Now, I started this talk by showing you this process, and I told you how users in today's way of using LLMs in today's paradigm are verifying the process, and I told you this was bad. I then proposed to you the Gorilla LLM, but keep in mind, the users are still here to verify the output, right? So you went from pre-factor validation to post-factor validation, which is great, right? You can now look at the output. But in this scenario, who's the bottleneck? The humans, right? If you want humans to verify every single output, you're just going to be bottlenecking the LLM itself. And I use LLM here generously to also include agents, workflows, and different systems that you might have. What we want to head towards is this: a world where you have a delayed and punctuated verification of the downstream output. You can see the word punctuation. So the idea here is that you're going to have agents and workflows interacting with each other, right? Services interacting with each other. And ever so often, you might choose to go in and look at what the LLM or the agent is doing. But the default case is there's no human in the loop, right? So that's a system we want to envision. If this is sounding too abstract, let's take an example that's grounded in some of the classical systems literature, right? So let's look at the Amazon shopping cart example. Today, most mature services are on microservices. So you have a set of users over there, and the shopping cart, I've shown a few components here. One is add to cart, checkout, detect fraud, and dispatch. And you can think of all of these microservices talking to each other using gRPC calls or RESTful API calls, so on and so forth, right? Now I'm going to claim, and this might already be happening today, is one or all of these microservices are going to be powered fully or partially by LLMs, right? So what changes? Let's take a simple example. I place an order for a red marker, right? So the checkout picks it up, and then the fraud detection says, okay, Shishir is reasonable, and then it goes to dispatch and inventory, and I get a red marker delivered to my home. I get a blue marker delivered to my home. I'm obviously unhappy, but the point here is that this is delayed, right? The checkout happened much long ago. I got my marker maybe 2 days later, and so now I have a delayed response and I'm not happy with it. But I also don't know where did the error happen, right? You can, of course, go back and diagnose and see what happened. But the point here is that your signals are delayed, and it's only downstream that's visible, right? So to formalize this, the problem of having human out of the loop is that you're going to have delayed verification. You're going to have only downstream outcomes are visible. And so our solution to this, like how do we fix this, is two-pronged. The first approach is to say, can I guarantee reversibility for LLM actions? Right? I dispatch an LLM agent that says, every time I get a Slack message, can you please respond on my behalf? I don't like the message. What do? I go and delete my Slack message. Some of you may recognize this does not work everywhere, right? What if I send an email? Can I undo an email? The answer is no. So in those cases where you cannot undo actions, can we give blast radius semantics? Right? So I can say, send emails only to my wonderful undergrads, not send any emails to my professors without asking me. So can you define such blast radius confinements? And the other thing that we want to do is provide a lot of the people who are today productionizing LLMs some ways to quantify the risk. So you can say, hey, do not cause more than 5 cents worth of damage. So how do we take this dollar cost value and then translate that to policies that can then actually enforce it? So long story short, with Coex, our goal is to build abstractions and policies to enable LLMs to execute actions in the presence of delayed and downstream signals, right? And the abstractions we are going to present is undo and blast radius confinement. What's the policy? Well, there's no one size fits all, remember? So I'm going to present you these abstractions and make it easy for you to build policies on top of this, and you can customize a policy to your liking. So that's the idea behind Coex. And one of the questions that we wanted to ask is, can we build Coex using tools that are available today, right? So one thing that we can do is go and talk to all the service providers and say, hey, for every API that you have, can you give me dry run semantics, right? So Kubernetes has this, AWS has this, where you can go and say, I'm going to dry run an API, or what they also call shadow run, and it's going to tell you, do you have all the permissions or not, or here's what the end state would look like. But that's not very, we like the code incremental deployment. That's not really helpful. You can't deploy as of it. You can't deploy that as of today. So the question we want to ask is, can we go ahead and build Coex using tools available? And so I'm going to present you some key insights that we had to build this as a tool. And the first is, if you try and understand what are the different services that people have and have a top-down approach, it becomes intractable, right? John look like Spotify, say, and then Daniel may like Netflix, and then I like a different service, and then it's going to be intractable real soon that you're going to have so many services out there. Instead, we said, let's take a bottoms-up approach, right? I'm going to divide all the services out there into 3 buckets. The first is RESTful API calls. The second is databases. And the third is file systems. And I'm going to present you abstractions for these 3. And then no matter what service is there, you can quickly onboard and build on top of these abstractions, right? So that's the idea over here. So how are we going to do this? For RESTful API calls, Coex will be the runtime that's going to maintain state. So if I want to delete an email, I'm going to download a copy of the email. We don't care about the UI, but you're going to have the content. And so when I delete the email, that's good because you still have the copy locally. You can see the problem, right? Every time I perform an action, I'm creating a parallel fork of the universe. So how do we optimize this in terms of storage? For snapshotting and versioning, the idea is, databases give you clear transaction semantics. File systems have, you can do like a transaction-enabled file system, journaling file system, but even outside of that, for classical file systems like ext4fs or NFS, you can obviously start with a Git or a Git LFS style semantics that can help you to undo, right? But the problem is these are not very robust. They're very robust, it's not very performant. So the goal is, can we make some optimizations here? For example, I want to make a change to our database. Can I create a copy of the schema of the database in a container, perform an action, try to undo the action, see if there's state matches or not, and then return to the user and say, hey, here's an API call, here's a negation of the API call, and it matches. Now, some of you may quickly recognize, but this is, I do not guarantee, there's no guarantees here, right? Everything's thrown to the wind. And my claim here is that I'm going to give you at most 1 chance to make a mistake. You can be wrong at most once. And every time you're wrong, I'm going to capture it and not make the same mistake again. Right? I'm going to claim that in steady state, this is going to converge to a set of API negation API calls that is pretty robust. So that's the idea there. And in the second case, how do we bound the blast radius? This is by doing scoping and permissioning, right? And we know how to do this very well with smartphones today. If you install a social media app, it'll ask you, can I get access to your gallery? Can I get access to your location? Can I get access to your microphone? And you can selectively choose which one to get. And you can think of more fine-grained ways of doing this using OAuth 2. Right? You can say, I'm only going to give you scope to do X for X amount, Y amount of time. And that's how you can go ahead and guarantee individual scopes and individual timelines to bound the blast radius. Right? So that's the guarantees that we have. Did we build the system? The answer is yes, it's open sourced. We also wrote a nice vision paper around it. I'm not going to go fully into the details, but the high level idea is presenting abstractions and some default policies for users, so you can go ahead and quickly use this when you want your LLMs to perform actions on your behalf, right? Why? Simple. Take the human out of the loop. So that's Coex, that's the execution engine. And across these three different bets that we have made, hopefully I've convinced you all that we have made meaningful progress towards realizing all three of them. So this is Gorilla, LLMs and tool use. What else have I done in my PhD? So I'm not going to go fully into the details here, but I'm going to give you a quick timeline, right? So when I came in, I said I'm going to work on ubiquitous computing and how do you make that intelligent, right? So the first thing that we did is, can we make inference on the edge optimized? And the way we looked at this was, back in the day, there was a few different techniques, right? Well, three precisely. One is quantization, specification, neural architecture search. And one thing that I realized working in ML is that people are emotional about their models, right? And anything that you do to change that is not going to be welcome. So the question we asked is, can we use systems-only approaches, right? Like paging and rematerialization to actually go and improve the inference. And oftentimes on edge devices, you don't have integers, you don't have floating point units, you have integer simulated floating point units. So then what does that mean and how do you reason about it? So the edge ML work was in that direction. And then POET was about, okay, if you have done inference on the edge, can you also go ahead and do training on the edge, right? So some of you might have heard of federated learning, where the idea is if different devices train locally, can you aggregate all the weights? Well, how do you even train locally, right? You're going to run out of memory. You're not going to have a whole bunch of resources. People forget that often in the cloud, a GPU can run to completion. No one's going to bother it. On the edge, if I was training something, well, guess what? The Zoom call now wanted access to my GPU. So that's preemption. So how do you take care of preemption on commodity edge devices, and how do you fix that? So POET was a work in that direction, and POET was a follow-on work for that. And finally, sometimes you might want to train in the cloud or locally. How do you bridge this gap, right? How do you now deploy the models that are trained at either of these places at the corresponding place? And so Nebula was a step in that direction, where we try to look at, can we use some of the underlying OS primitives to support efficient deployment? And then I said, let's move from one extreme of computing to the other extreme, which is sky computing, right? So let's look at what does it mean to move data and how do we do it efficiently across multiple cloud providers. I also took a quick vacation and worked on data center deflection switching, which was pretty fun. But anyways, and post that, I presented to you some of our work on LLMs and function calling, and how do we enable this and how do we make this real. So coming back, I'm very proud of those animations. So coming back to the slide, this would be, I want to stop here. This concludes the technical part of this talk, and I want to see if people have any questions.
So if you go to the previous slide, is that you're done?
Technical question, yes. Okay.
Please. I'll wait for
Okay.
everything else.
Yeah. I see some chat.
I was looking, I didn't see, maybe there's chat.
So the slides are being screen shared.
That was from the beginning.
Okay.
Yeah.
All right. Okay. Excellent. So if there's no more, that's great, because I have a lot of people to thank. So I'm gonna see the animations again. So I want to start by thanking three folks who had the most significant impact on my PhD. Oftentimes when I listen to talks, people start with, it's been my honor and pleasure. I've never understood what each of those phrases meant individually. But as I was putting this talk together this morning, I now understand, and I mean it when I say it's been my honor and pleasure to have worked with Joey, Prabal, and Dion. So when I started working with Joey, what I really appreciated is his abundance of enthusiasm. As you saw, I've gone to him with ideas in edge, ideas in data center networking, ideas, some to say MLSS is dead, ideas in cloud, sky, so on and so forth. And has always given me the same enthusiasm and feedback that I've come to appreciate. And I think my interaction with Joey is best summarized by what Jean-Luc said. He once sat in on our 101, and he said, the way you talk to Joey is like you talk to a colleague and not to an advisor, which is very true. So Joey is very approachable, that I've really benefited and appreciated. And Prabal, my first interaction with Prabal in person, after the pleasantries, I told him, I'm going to leave with a master's. And he said with a very straight face, okay. I don't know what that means, but that just goes on. That's quite essential of Prabal, right? I've told him multiple different things. and he's always given me the freedom to explore it. And much later on, as I went to other schools during my visit days, I was told that's a strict no question. You never start off on your prospective advisor by saying, I'm going to leave in 2 years and take your money for it, right?
You had to be told this?
These are different cultures. But yeah, so Prabal, thank you so much for giving me the freedom to explore all the different ideas. And Jan, when I started working with Jan, what I've come to appreciate has been very honest and very open with me. And so oftentimes when I go to him for career advice, there's 2 things that he has told me that I'm going to carry for the rest of my life. 1 is relentless focus. And 2 is just do the right thing. And when you say this to me first, I think his advisor told him about do the right thing. It almost felt like euphemism, almost like he was ignoring trying to answer my question. But over time, I've realized what those means, right? Like, oh, should I do this extra reviewing or be on this PC? And he's been like, why do you not have interesting research to do? So trying to go back to the basics and focusing on doing the right thing and the relentless focus has really helped me. So I want to thank all 3 of you for first being very open with me. And that's a privilege that I really enjoy, and giving me all the feedback and giving me the freedom and supporting me and advising me over the past many years. I also want to thank Chris. So I met Chris once in 2018, although he does not remember any of it. But I did meet him a few times more in South Bay, even before I asked him to be on my committee. And he was very open and shared with me his how he thinks about making decisions, how he made his career decisions. And that's been like super helpful. So thank you, Chris. And also for giving feedback on my quals. He's part of my quals and my dissertation committee. I've had the honor of working with Reluka twice, once on the Minerva project and once on the Coex project. And she's been very available to me across just for pure research, right? Oftentimes, when you have research conversation for a long period of time, you tend to lose focus, etc. But Reluka, we could ping her any time of the day and she'd be like, here's my Zoom call, let's chat research. So that's been super nice. I've had a chance to work with Mehdi on the Raft paper, and I've really appreciated the feedback he has given us, and he's very grounded. You could never excite him, never annoy him. So that's been interesting. And so Kurt and Sylvia both were instrumental in getting me to Berkeley in their own ways. Sylvia convinced me there was a lot of good vegetarian food at Berkeley and made me feel very homely and welcome in my first few months here. And I've also had the pleasure of TAing for her, GSIing for her in CS268, and also working on a very fun project on deflection switching as well. So thank you to all the professors at Berkeley. And I also want to take this chance to thank a lot of my collaborators, not just here at Berkeley, but also at MSR and at ISC. So Pratik, Vivek, and Harsha were my mentors at Microsoft Research, and Professor Emma Nayak was my mentor at the Institute of Science, and I really got my footing as a researcher back there before I came to Berkeley. And since then, I've worked with Sam on the Minerva project. Sam, very rigorous, very dedicated, so I've learned a lot from that. So Alvin Van is a very interesting story. Alvin was a PhD student in this lab, worked on edge computing for 3 years. I was a PhD student in this lab, worked on edge computing for 3 years. I met him exactly once, 1 week before he graduates, at an event in the Haas Business School. And so, Joey, the problem is, this is 100% your fault. But since then, we have gone to be extremely close friends. And if any of you want to intern or have a manager, Alvin, hands down, the best manager you'll ever have. So yeah, I've really appreciated all the interactions with Alvin. And when I tell people about where I interned, with most people, I tell what I worked on. With Alvin, I just tell I worked with Alvin, and pretty much almost everyone in the Bay Area knows him. So yeah, and Martin and I started talking very early on about some of my research at a party. And we were the only 2 people chatting about edge computing. And since then, he's been a collaborator. We have worked on very wild ideas, like trying to declare ML for systems is never going to work. We didn't quite declare that, but then he's been also very helpful on the Coex project, trying to brainstorm some of the ideas. And he actually came up with the first suggestion for trying to build such a runtime. So I've enjoyed that collaboration. Among PhD students, so Tianjun and I have worked extremely deeply over the past couple of years. And he's been an absolute rad to work with, always engaging me with his wit and humor. So that's been like super fun, extremely strong. Now, Jean-Luc and I only worked on a single project called Minerva, but more critical, when I came to Berkeley, Jean-Luc was one of the first few people whom I met. And he's been very welcoming, acknowledging that I've come from different backgrounds and made me feel very welcome at Berkeley. And he has also taught me how to ski, and we both have taught each other how to sail. So yeah, it's been very fun. And I've worked very deeply with sparse initially on the Port project and with Vivian increasingly on the Gorilla and the Coex projects as well. And so thank you to, not going to go list everyone, but thank you to all the collaborators with whom I've had the honor of working. I've learned a lot from every single one of you. And fundamental to Gorilla success has been our undergrads. Some of them are in the room today, and I've really gotten lucky in picking some of Berkeley's finest undergrads. And I almost treat them as 30th PhDs now. We discuss on what needs to be done, and 3 weeks later, I do my part, they do their part, and then we just go ahead and release it. We really haven't had to much. When people say, oh, look, here's a problem. I've never really come across many of that with undergrads. So yeah, thank you for joining me in this journey. Okay, the social aspect. Now, PhD can be a lonely time, not for me. I have never had an experience where I've been like, oh, this is lonely, etc. I've had the most fun at Berkeley, and I'm pretty sure of all the pictures over here, Berkeley paid for pretty much all the fun that we were having. So no, it's fantastic. I think, and especially during the pandemic, Samir, Jean-Luc, and I would do a bunch of things. That was the only time where we couldn't get reimbursed, but often pretty much everything has been on Berkeley's time. But I've really had a lot of fun here. And like I said, when people say PhD could be a lonely experience, I just cannot relate. It's out of my vocabulary. And I think Connor and Lisa have big roles to play in trying to make the lab a lot more engaging. And I would like to also thank myself for being and not just members of the lab, but I've also very often visited South Bay and San Francisco. So all my friends there, Sundar and Ayush also made the long trek up here from South Bay today. But just trying, especially post the pandemic, I think at one point, okay, I should not say the number, we were attending way more parties in Rains and some of the Stanford places than what would be considered normal. Also, a lot of festivals that we celebrated in South Bay as well. Well, not a lot, but hopefully a lot more of high teas that I will now come to enjoy in San Francisco. So yeah, thank you all for just being there. And I'm 100% sure we're going to continue to have fun, independent, me being a doctor or not. I also want to thank Shirley and Jean. So I told Prabal I'm going to come here only to leave with a master's, but I've always felt I'm going to do a PhD until I got an email saying that Shirley was leaving. And that was the point where I think a few of us thought, okay, graduation might actually be hard. So Shirley and Jean have been super helpful to me throughout my PhD. This includes like getting extremely legal letters as I've tried to get visas for a bunch of places to travel, etc. And also Kat, John, Ivan, and Kaylee have been super helpful as well, including today when I told them I want to do some A/B testing. I think there was a meeting with 11 people before this in this room, and they got everyone out 10 minutes before. So
Supposed to be in that meeting.
well, so yeah, thank you for them. And last but not the least, I think many of you will know is that I have a very close relationship with my parents, my mom and my dad, and my mom has continued to call me every day since then. Since I've left Bangalore. So Berkeley was the first city I visited outside of Bangalore to stay. So I've been at home most of the time. And so my mom and dad have first inculcated in me the rigor, the nature of hard work and just trying to be there, supporting me. They don't understand a whole bunch about what I do, but they try to read pretty much everything that I write and have been super helpful asking me if I'm doing what needs to be done. So thank you to my mom and dad. And finally, I want to conclude by saying, there's a few bets that I think I really believe in, and hopefully some of the works that we have done have advanced these bets and are going to take it to fruition. So thank you very much. So I